Today's lesson, we're going to be working with the Pythagorean Theorem in the coordinate plane. So first of all, we need a quick reminder of what the Pythagorean Theorem is. In this case, it is a squared plus b squared equals c squared. A couple of things I want you to remember is that a and b are the legs of your right triangle, and that c is the longest side, which we call the hypotenuse, and it's always across from the right angle. So in today's lesson, what we're going to be exploring is finding the distance and using the Pythagorean theorem to do that. So here, I'm going to find the distance between the given points. So first, I need to graph these 2 points on my coordinate plane. So 9, 0, that's going to be over 9, down 0, which means it's going to be on your x-axis. 1, negative 6 is going to be over 1, down 6, 1, 2, 3, 4, 5, 6. So what they're asking me to do right now is to find the distance between these 2 points. So the first thing I want to do is connect these 2 points to know what I'm finding the distance of. And since I don't know it, I'm going to go ahead and label it a variable. I'm going to use d because it makes me think of distance. So now, since I'm trying to find the distance of this line and I'm expected to use the Pythagorean theorem, I need to somehow form a right triangle. And the way I do that is by doing this. You're going to notice I am creating a right triangle with the given distance that I have. So now that I have a right triangle, I can now use the Pythagorean theorem. But the thing about using the Pythagorean theorem is, in order to find a missing length from a right triangle, I need to at least have 2 of them. So in this case, I'm going to have to figure out what these 2 lengths are. It's as easy as counting how many spaces are represented to represent this length. So here, it's 1, 2, 3, 4, 5, 6. Hopefully you notice I counted the boxes in between, which are called units. I didn't count the lines. Because what happens sometimes is students will often count this as 1, and then they'll end up with 1, 2, 3, 4, 5, 6, 7, and it will throw off their answers. So a good thing to remember is, instead of counting the lines, count the boxes that make up the length of things. So I'm going to do the same thing here. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. This is 8. So at this point, I have the 2 lengths that I need to plug into my formula. So the Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to square the legs. So 6 squared plus 8 squared equals d squared. I'm going to simplify what I have. 6 squared is 36, 8 squared is 64, and that equals d squared. Now I'm going to combine these 2 because they are like terms. It's going to give me 100 equals d squared. But I'm not done quite yet. I still need to take the square root of both sides, which would leave me with d equals positive negative 10. However, when we think about it, if I'm looking for a distance, would I ever describe the distance as being negative 10? The answer is no. So I'm going to answer this question as the distance is 10, and since there was no units given, I would just say units. Okay. Now let's look at our second example here. Now I'm going to expose you to a little bit more information to kind of prep you for tomorrow's lesson. I'm going to do the same steps and plot the points that I'm given. So it's negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 3 since it's positive. Then I have positive 4, negative 2, so I'm going to go to the right 4 and down 2. So what I'm going to do is try to find the distance between these 2 points here. And this time, what I want you to notice is, before I went and created a right triangle facing this direction. In this one, I want to show you the opposite. So instead, I'm going to draw it as if it's upside down, what you would consider upside down. It really does not matter which way you view the right triangle, no matter what. The lengths of the legs are going to be the same no matter how you draw it, so feel free to do it either way. You'll still get the same answer. So here, what's going to happen is, again, I'm trying to find the distance. So I'm going to go ahead and label that D. Here, I'm going to count this as rise. Why am I doing that? Because this reminds me of slope. There's a rise and there is a run. So I'm going to go ahead and figure out what the run is of this graph here. And how do I determine run? Well, I determine run by seeing how it changes in terms of the x values, because run runs left to right, which is the x coordinates. So looking here, I'm noticing that a -8 became a +4. So what do I do here? I like to view it as this. So I'm going to go ahead and call it run. And I want you to also notice that this is one of the legs. So I'm going to call it leg 1. I went from a -8 to a +4. The way I like to think of it is, because I'm going from a totally different sign, I understand that I have to cross the number 0. So what happens is -8 to 0 would require me to add 8, and 0 to 4 would require me to add 4. So altogether, I had to move 12. So since this is positive, I'm going to say that length is 12. Now let me just check to see if I'm right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I am correct. So why am I doing this when I can count the squares here? Well, tomorrow's lesson, you're not going to be given a coordinate plane, so you won't be able to graph it and visualize it. So here, this will allow you to understand that this is your, basically the leg of a triangle could also be considered the run. Now, here, I would call this the rise. So notice rise goes up and down, which is your y-axis. So this time, I'm going to focus on the y coordinate. So how did 3 become -2? Well, this, real quick, I'm going to go ahead and label it like 2. It went from a +3 to a -2. So notice it's crossing from one sign to the opposite sign. So it must cross the number 0. So I like to put that in between. So how did 3 get to 0? Well, I had to subtract 3. Then how did 0 become -2? Well, you have to subtract 2. So altogether, I subtracted a total of 5. Now here's something that you need to think about. Is it possible to consider length as -5? The answer is no. So in math, we do have something called the absolute value. It looks like bars kind of around a number. What the absolute value represents is the distance from 0. So notice here, I'm going to say the distance from -5 to 0 is 5. Why? Because again, distance can't be negative. So that's the reason why I took the absolute value. But basically what you need to understand is there is no such thing as negative distance. So now I have 5. Let me check with my diagram if that matches. 1, 2, 3, 4, 5, and guess what? It does. So again, using this method is going to be nice because you won't be reliant on a graph. Why don't you want to be reliant on a graph? Well, because number 1, you won't always be given a graph. Number 2, what if your numbers are ridiculously large? What are you going to do? And 3, what happens if you're given decimals? That's going to complicate things. So we're going to eventually translate to this, and you're going to see what's called the distance formula tomorrow. So now, since I know the two lengths of the legs, which is 12 and 5, I'm going to go ahead and plug it into my formula. So here I have 5 squared plus 12 squared is supposed to equal d squared. 5 squared is 25, 12 squared is 144, and that's supposed to equal d squared. I'm going to combine these two terms, and I'm going to get 169 equals d squared. Please note, I'm trying to find the value of d, so I'm not done. I still need to take the square root of both sides. So the square root of 169 is positive and negative 13. But yet again, I would never describe distance as being negative, so I get to eliminate that option and say the distance is 13 units. Again, please don't forget to put the word units. Now, let's go over to the next page. So now, for this one, I'm actually going to challenge you a bit. Instead of having you graph, I'm just going to have you envision as though you weren't given one. What are you going to do? So I'm just going to eliminate this graph right here. Okay, if you still need the graph, that's totally fine, but we're going to try for this one. Here, I want to find a rise, which is considered one of the legs. I'm going to call it leg 1, and one of the runs. I'm going to call that leg 2. So here, rise, again, rise is going from an up and down motion, which is your y-axis. So I'm going to focus on the y-coordinates. How did 5 become 9? Most of you can do that in your head, and you can say, okay, well, it has to add 4. So what is the absolute value of 4? So what's the distance from 4 to 0? I would just say 4. And that makes sense because distance can be positive. Now run runs from left to right, so I'm trying to see how it's moving from left to right, how far it's moving to be exact. So that's going to be my x value, so I'm going to check how did 2 become 6. And again, most of you can do this in your head. You're thinking, okay, so I added 4, so the absolute value of 4 is again 4. Now I know the 2 lengths of the legs. Okay, so I'm going to go ahead and plug it into my formula. A squared plus b squared equals c squared. So 4 squared plus 4 squared equals, I'll use d squared like before. 4 squared is 16, 4 squared is 16 equals d squared. I'm going to get 32 equals d squared. You're not finished yet. Please remember, we still need to take the square root of both sides. You're going to notice the square root of 32 is not a nice whole number, so I'm going to have to approximate. And if you were to plug that into a calculator, again, what you're going to want to do is put the number 32 first, and then click the square root. This is often what you're going to have to do for very simple calculators. Okay, so I'm going to round my answer to the nearest 10th. So this 5 will make the 6 go up. So my final answer would be that D is approximately 5 7/10 units. But remember, they're asking me for distance. They didn't ask me for D. So my final answer should actually be the distance is approximately 5 7/10 units.